Hi, this is Mr. Hood, and we're going to talk about expressing decimal numbers in scientific notation. For example, the radius of an atom is about 5, take a guess, 10 billionths of a meter. So if you want to estimate how big that is, find a meter stick, a really good pair of scissors, slice it into 10 billion equal parts, take 5 of those parts and mush them together, and you've got a distance about the radius of an atom. So we're talking pretty small. So you can imagine as a mathematician or a scientist, it would get really old having to write all those zeros all the time. So we came up with a shortcut called scientific notation, and here's how it works. The first thing we're going to look for is the first non-zero digit. In this case, it's 5. Then we're going to look for the last non-zero digit. Well, in this example, 5 is the only non-zero digit, so we're going to write that number beneath. Next step is that we're going to write a decimal point after the first digit. Now, in this particular case, this is not going to end up being necessary, but as a good force of habit, let's go ahead and do it anyway. Now, scientific notation consists of two parts. There's a base number, and then there's a power of 10. So we're going to take that base number of 5 and multiply it by a power of 10. Well, how are we going to figure out what our power of 10 is going to be? We're going to have to do some counting. So we want to count the number of decimal places from where we just put the new decimal place, which is to the right of the 5, back to where it used to be, right there. So let's count. I got 10, so our exponent is going to be 10. But an exponent term of 10 to the 10th power would imply that we have a really, really large number, and this number is really, really small. So as it turns out, in cases where you start with numbers that are positive but between 0 and 1, we use a negative exponent. And again, it's negative because the original number is a small positive number less than 1. So, since we have a decimal point to the right of the 5, but no digits to the right of the 5, we can get rid of that decimal point as well. So the radius of our atom is 5 times 10 to the negative 10th meters.